the facts with regards to complementary and supplementary angles. So first we will talk about complementary angles. Now, do you think that two acute angles can be complementary? Now, before that, what are acute angles? Those angles whose value is less than 90 degrees. So angles measuring less than 90 degrees are called acute angles. So let's say you have two acute angles. So can they be supplementary? That means, is it possible that you add up two angles lesser than 90 degree and the sum would be 90 degree? Let us look at these examples. Let's say this is one angle which is maybe 50 degrees. This is another angle which is 40 degrees. So when you sum them up, it is 90 degree. These two together makes 90 degree. Therefore, these two are definitely complementary. So yes, two acute angles can be complementary. Let us look at a few more instances. Now this is 90 degree, right? So this is a right angle. Now let's say if you have two angles like this. One angle is smaller than the other. Their sum is 90 degrees. Similarly, you might have a situation like this, where this angle is very small and this angle is quite big, but both of these are acute angles. So their sum can be 90 degrees. Now, there could be a scenario where this angle is very small, but this angle is quite big, and again the sum is still 90 degrees. So therefore, all of these are complementary angles. So definitely two acute angles can be complementary. Now, do you think that two obtuse angles can be complementary? No, they cannot. Because what is an obtuse angle? An obtuse angle is the one whose measure is greater than 90 degree. Now, we want the sum to be 90 degree for complementary angles. Now, if one angle itself is greater than 90 degree, so there is no chance that it can add up to some other angle to form 90 degree, right? So, two obtuse angles can never be complementary. Now, do you think that one acute angle and one obtuse angle can be complementary? Definitely not. That's because again, one obtuse angle itself means greater than 90 degree. So you add anything to something greater than 90 degree. So obviously you are going to get something which is greater than 90 degree. So therefore it is not at all possible that if either of the angle is an obtuse angle, the sum can never be 90 degree, and therefore an obtuse angle can never be part of complementary angles. So obtuse angle would be something like this, which in itself is greater than 90 degree. Therefore, they can never be complementary. So let us say, let me take an example. Let's say the value of this angle is 120 degree, which is obtuse angle, and the value of this one is 30 degree, which is acute angle. So when you try to find the sum would be 120 plus 30, which is 150 degree. So do you think it is 90? No. And it is actually not feasible because one value is itself greater than 90. So how can the sum be equal to 90? So obtuse angle cannot be complementary. Two right angles cannot be complementary again, because one right angle means how much? One right angle is exactly equal to 90 degree. So in order that this right angle is complement of some other angle, the other angle has to be 0 degree, which is actually nothing. Therefore, two right angles cannot be complementary again. Now, let us look at some similar facts on supplementary angles. So let us quickly look at the facts with regards to supplementary angles. Now, do you think that two acute angles can be supplementary? No, never. Why? That's because both of these angles are less than 90 degrees. Now, let's take an example. Let us say that you have two acute angles. Maybe one angle is somewhere around 45 degree, and let's say the other angle is 70 degrees. So let's assume these are the angles that you have. So what would be the sum? So the sum would be 70 plus 45, which would be 115. So do you think that this is equal to 180 degrees? No. So basically you think of any acute angles. Let's try to think of the maximum possible acute angle, maybe something like 89 degrees. So even if you have two 89 degrees, just add them up. how much do you get? You get 178 degrees, which is still less than 180 degrees. Therefore, supplementary angles cannot be formed by two acute angles. Two obtuse angles cannot be supplementary again. Now that's because when you consider two obtuse angles, now each obtuse angle is greater than 90 degree. Now when you add two obtuse angles, then the sum becomes greater than 180 degree. So with two obtuse angles, sum becomes greater than 180 degree. With two acute angles, the sum is less than 180 degrees. So because of these, neither two acute angles nor two obtuse angles can be supplementary. So this should be supplementary. However, one acute and one obtuse angles can definitely be supplementary. So this is a typo. So this should be supplementary. So if you take one acute angle and one obtuse angle, then that can be a perfect supplementary angles. Let us have a look at some examples. So let's look at this one. So let's say that this angle, now this is definitely supplementary angles because the sum of these two angles is definitely 180 degree, which is a straight line, right? So here when you look at this angle, this is obtuse, it is greater than 90 degree, right? 90 degree would have been something like this. This would have been 90 degree. So it is greater than 90, so this is obtuse, and this one is acute because it is less than 90. So one obtuse, one acute make a perfect supplementary pair. Similarly, even if you think it in this way, let's say that you have something like this. Instead of this, if you have two right angles, this is also 90 and this is also 90. So both of these are right angles. So do you think they make a supplementary pair? Yes, definitely. So here also this is talking about supplementary. So two right angles is always supplementary because 90 degree plus 90 degree forms a 180 degree. So basically two right angles will always be supplementary. Yeah, so these were a couple of things with regards to complementary and supplementary angles. Now, what do we mean by adjacent? Even before we talk about adjacent angles, let's first understand what is adjacent. Now, what do you see on the screen? We see maybe a restaurant or a dining hall where you have tables and chairs where people can sit and eat or maybe have coffee or something like that. Now, how do you think that adjacent word is related to this restaurant or this dining area? So that's because I'll like to give you an example. Now let us say that you are sitting in this chair and your friend is sitting on this chair, and let's say that this is your brother who is sitting on this chair. Now, where is your brother sitting with respect to you? So this is you. This is your brother and this is your friend, right? Now when you look at it, you see that you and your friend, you are sitting next to each other. You are sitting beside each other, right? So both you and your friend are on the same side of the table, whereas you and your brother are sitting on the other side of the table. That is, you are sitting opposite to each other. Right? So this is what I'm trying to tell. So whenever two persons are sitting next to each other, they are said to be adjacent. And when two persons are sitting opposite to each other, they are said to be sitting opposite to each other. So here we are going to talk about the adjacent angles. So the word adjacent means next to something, whether it is you and your friend sitting next to each other, or it is about some angles which are sitting next to each other. So two angles just beside each other are termed as adjacent angles. Now what do we mean by angles beside each other? That is what we will understand in the next slide. So adjacent angles are those angles having a common vertex and a common arm but no common interior points. Now these are very important. So in order to decide whether two angles are sitting next to each other or not, we will have to check that they should share a common vertex and a common arm. So this would prove that they are actually sitting next to each other. But there is an important criteria that there should be no common interior points, so that we know that they are actually sitting next to each other and not within each other. Right? Let's look at this example. So here, let me take examples of these two angles. Let's consider this angle. Let's call this angle 1 and let's call this as angle 2. Yeah. Now, if you compare angle 1 and angle 2, so do you think that these angles are located next to each other? Now, just by looking at the diagram, you should not say. That's because here you might easily say that, yeah, they seem to be located next to each other, so they are adjacent. But you will have to follow these criteria to understand that how these criteria prove that the angles are adjacent. Now, they share a common vertex. So, that common vertex is this. So, this is the common vertex that they share. Do you think that they share a common arm? Yes, this is the common arm that they share. So this one is the common arm. So okay, so this proves that they are located next to each other. So do they have common interior points? Now when you talk about angle 1, so which area would be, where is that location where the interior points would be located? So somewhere in this region. When you talk about angle 2, where would be the interior points located? Somewhere in this region. So do you think that there can be any point which would be common to both 1 and 2? No, because for 1 the region is this and for 2 the region is this. So they will not have any common interior points. So therefore all the three conditions are satisfied, and this proves that angle 1 and angle 2 are adjacent. Now you might ask that, okay, only with common vertex and common arm we can see whether they are adjacent or not. So why do we need to have this third criteria that they should not have any common interior points? That is because, now let us say if I ask you whether angle 1 and this angle, that is angle 3, let me call this angle 3. So do you think that this angle 1 is adjacent with this angle 3? Now here also, if you start looking at point by point, so this angle that is formed by these two arms, this also has the same common vertex. Now for this angle and this angle, you have a common arm, that is this arm is common, right? So first two criteria are getting satisfied. But when you look at the third criteria, so for angle 3, this entire region would be for the interior points, and for angle 1 this region would be for interior points. So basically the region interior to angle 1 is also interior to angle 3, so they will have common interior points, and that is where we will say that angle 1 and angle 3 are not adjacent angles, correct? And also looking at this, you can see that angle 1 is like a part of angle 3. So basically we can't say that they are sitting next to each other. They are not sitting next to each other. Angle 3 is occupying a huge space. Out of that, a small space is given for angle 1. Right? So angle 1 is basically sitting in the territory of angle 3. So angle 1 and angle 3 are not adjacent, whereas angle 1 and angle 2, they are adjacent. So this is where these three conditions help. So only when the three conditions satisfy, we can say that two angles are adjacent angles. So let us take one more example. So what do you think? These two angles, this is 90 degree, this is also 90 degrees. So now by now we know that these are supplementary angles because their sum is 180 degrees. But do you think that they are adjacent? Yeah, kind of, they appear to be, because they appear to be sitting next to each other. But let's look at it condition wise. They have a common vertex. So this is the common vertex. Do they have a common arm? Yes, this one is the common arm. What about common interior points? Now for this angle, this region would be the interior region. For this angle, this region would be the interior region. So they cannot have any common interior points. Therefore, we can say that these two angles are also adjacent angles. Now let us look at some of the examples here and let's try to see if these are adjacent or not. So this one, do you think angle 1 and angle 2 are adjacent? No. Why? Because they do not satisfy the first criteria. They do not have a common vertex. So no common vertex. Therefore, is this adjacent angle? No. So see, for angle 1 the vertex is this, for angle 2 the vertex is this. So they do not have a common vertex. Let's look at the next one. So here what do you think? Are they adjacent angles? Not again. That's because again when you look at angle 1, which is the vertex for angle 1? This is the vertex. Which is the vertex for angle 2? This is the vertex. So again they do not have a common vertex. So therefore here also these are not adjacent angles. The third one, angle 1 and angle 2. What about this? So here we do see a common vertex. So here we have a common vertex. Fine. Do we have a common arm? So for angle 1, what are the two arms? This is one arm, this is another arm. So this is one arm and this is one arm for angle 1. For angle 2, this is one arm and this is one arm. So basically here we do not have a common arm. So here no common arm. Therefore these are also not adjacent angles. But by any chance, if we would have asked if angle 1 and this angle 3, if these are adjacent or not, then definitely they would have been, because they would have a common vertex, they would also have a common arm, and they also do not have any common interior point. So angle 1 and angle 3 would have been adjacent angles. Anyways, let's look at the fourth one. What do you say? Angle 1 and 2, are they adjacent angles? Not again, because here also if you look at this angle, this is the vertex. You look at this angle, this is the vertex. So they do not have a common vertex. So no common vertex. Therefore, these are also not adjacent angles. So you see, looking at the figures, you will have to determine whether they are adjacent or not. So the important thing to remember is these three conditions: common vertex, common arm, no common interior points. Thank you. About adjacent angles, we are going to talk about linear pair. This is another interesting pair of angles. So a pair of adjacent angles whose non-common sides are opposite rays. Now by now you already know what are adjacent angles. Now let us try to understand what are opposite rays. Now we all know ray. Ray is that part of a line which extends only in one direction. So other side is fixed, but this end is extending infinitely. So that's a ray. So when we say opposite rays, that means two rays which are extending in the opposite directions, somewhat like this. So these are opposite rays. Whereas if you have two rays which are extending in the same direction, then they are non-opposite rays, or you can say they are the rays extending in the same direction. Right? So that ways we have opposite rays, meaning the two rays in exactly opposite direction to each other. Okay, now let us try to understand the definition of linear pair. So linear pair are two such angles which are adjacent, that means which are located side by side. They should satisfy all the criteria to become adjacent. At the same time, their non-common sides are opposite rays. Now when you think of any adjacent angles, let us look at this example. So do you think that this angle 1 and this angle 2 are adjacent? Yes, of course, because they have a common vertex. Which is the common vertex? This point is the common vertex. They also have a common arm. That common arm is this arm, right? So this is the common arm. This is the common vertex. So which are the non-common sides? So this is the common side, right? So the remaining side is this one, and the remaining side for angle 2 is this one. So these are the non-common sides. And when you look at the non-common sides, these are rays which are opposite rays, they are actually extending in the opposite direction. Opposite means it needs to be exactly opposite. Now, if two rays are exactly opposite to each other, what would be the angle formed between them? The angle formed between them, this angle, would be nothing but a straight angle, that is 180 degrees. So two opposite rays will always form an angle of 180 degrees. Now in this case, we say that angle 1 and angle 2 form a linear pair. So linear pair would mean that basically the two angles will be adjacent, plus the non-common sides need to be opposite rays. That is, they also need to make an angle of 180 degree. So based on this, what do we see? In order to become a linear pair, two angles should satisfy these two conditions. They should be supplementary, that is, sum of the two angles should be equal to 180 degree. So as you can see here, so these two conditions are satisfied. First condition is that angle 1 plus angle 2 should be equal to 180 degree. And the second condition is that angle 1 and angle 2 should be adjacent angles. So if these two conditions are satisfied, then the two angles are said to be linear pair. Now why are they called linear pair? Now the term linear means a line. So two angles forming a line. So here you can see angle 1 and angle 2 together form a straight line. And that is why they make a straight angle. So that is why they are called linear pair. Now let us look at some of the examples and check which is linear pair and which is not. So let us look at the first one. So do you think this is a linear pair? So this angle, let's call it angle 1. And let us call the other angle, angle 2. So do you think they are linear pair? Yes, because they are adjacent, they have a common vertex, they have a common arm, they do not have common interior points. So angle 1 and angle 2 are adjacent. What about supplementary? Now angle 1 plus angle 2 together form a straight line, that is 180 degrees. So angle 1 plus angle 2 is also equal to 180 degrees. Therefore, yes, they form a linear pair. Let's look at this one. So here also, if you look at this, let's call this angle 1, let's call this angle 2. So here also it is exactly the same thing. They both lie in a straight line. So they form 180 degrees. They also have a common vertex, a common arm and no common interior points. Therefore here also, yes, they form a linear pair. Let's look at the third example. So here you have angle 1 and angle 2. Now when you look at the sum of angle 1 and angle 2, now this is an obtuse angle and this is an acute angle, and let's say that they satisfy this criteria, that is the sum of the two angles is equal to 180 degree. But do you think that they are adjacent? Do they share a common vertex? No. So the vertex for angle 1 is this and the vertex for angle 2 is this. So we can say that there are no common vertex. Now since there are no common vertex, therefore angle 1 and angle 2 are not adjacent. Now if they are not adjacent, they cannot be linear pair as well, because in order to become linear pair, they must be adjacent and they should also be supplementary. So what about this one? Here you have angle 1 and angle 2. Now of course these are adjacent because they have a common vertex, they have a common arm, there are no common interior points. So definitely angle 1 and angle 2 are adjacent. What about their sum? Now, do you think that the rays are exactly opposite to each other? This is one ray, this is another ray. Now had you been thinking of a ray which is running exactly opposite to each other, the ray would have been somewhat like this. But here it is like this. Therefore, in this case, angle 1 plus angle 2 do not make a straight line. Therefore, the sum is not equal to 180 degrees. So here also both the conditions are not satisfied. Therefore, 1 and 2 do not form a linear pair. Let us look at the last example. So here you have angle 1 and angle 2. So in this case also, angle 1 and angle 2 are adjacent. because of the common vertex, common arm, no common interior points. But when you look at their sum, do you think that their sum is equal to 180 degrees? No, because very distinctly you can see that it is an obtuse angle which is less than 180 degrees. So therefore, this would also be a no. So this also doesn't form a linear pair. So in this way, you will have to find out whether two angles form linear pair or not.